Welcome to the Weekly Squeak, your weekly geeky squeak with me, Christian Schiller. You can find more about the show at christianschiller.com/podcasts. Apologies for no show last week. I was out recording lots and lots of interviews at KubeCon, the Kubernetes conference in Barcelona, and then I had some other travel too. I also went to the weirdest conference, but one of the best I've ever been to in my entire life, and I go to a lot of conferences. That was the Code Garden from Umbraco in Odense, which is, I know, not how you pronounce it, but it's how my Anglo way would pronounce it in Denmark. I didn't really know very much about Umbraco when I got there, but I had a very good time, and the Thursday night bingo party was perhaps one of the strangest experiences of my life. But good. Anyway, this week I have an interview with Mark Marron of Microsoft's Bosque language, a new sort of prototype stage language that has some interesting constructs in it. And we had quite a fascinating interview about the history of programming languages, about the future of programming languages, and all sorts of other things. But let's kick off the show with a handful of links. First, more news from Microsoft. I've got two companies dominating my news items this week a little. This is from the Microsoft blog about Edge being available for macOS again. The first time there has been a Microsoft browser on macOS since Internet Explorer 5.5, which I remember. I can't entirely say if I remember it fondly or not. This was in the macOS 9 days, pre-OS X, pre-OS 10, however you want to call it. And this is the first Microsoft browser back on macOS. It's a Chromium skin, so it's Google Chrome-esque. Also, it reminds me a little bit of Brave, various other browsers that use Chromium under the hood. I have been playing around with the beta for a little while. I haven't done too much with it yet, so I may have some more hands-on news soon. But strange, Microsoft have become a very different and odd company and much more open-minded to these things. And I was actually sort of slightly surprised that having a Microsoft browser back on macOS wasn't greeted with as much kind of fanfare as I would have expected. I guess a lot of Mac users these days have not been using the Mac as long as I have and don't remember when we last had Internet Explorer, or Edge as it's called now. Not necessarily much to read in this blog post, but if you're interested in trialing it, and it is cross-platform, mostly cross-platform on desktop and mobile, then head over to the blog and give it a whirl. Next, in new applications coming to desktop is an application I think I have spoken a little bit about on the podcast, but I've definitely written about a lot. And this is a little niche, but I'm going to promote it anyway. This is a tool called Vale. Vale is a language linter made by a very helpful and friendly programmer over in Portland. And I've been using it a lot on text editors in Visual Studio Code and Atom and on command line to lint my technical copy, or you could use it for other copy too, for various styles that I want to check for, things like passive voice, future tense, in-house style guides, etc., etc. Up until this point, it has just been a command line and editor tool. But the developer has for some time been working on trying to expand it out onto desktop, including Word, Google Docs, and other uses. And I have been trialing the Vale server that enables just that. It's early days. I found a few issues already that I need to let the developer know about. But if you're interested, you can go and read this blog post, and he may let you into the testing program if you so desire. And you can test Vale to see how well it works on the desktop aimed at less technical users. And I find this quite fascinating because it is effectively an open source tool. The server component, not so much, but the kind of core of it and the ability to create your personal style guides and things like that is definitely an open process. So it's something that everyone in your team could potentially share in the coming months. This is especially relevant at the moment because Grammarly, which I guess is one of the equivalent tools in this world, although it's not very friendly for tech writers, you have to use a browser extension or the custom desktop application they have, had some controversy with its privacy policy. So if you are wanting to check private documents, then Grammarly may be no longer useful for you. And Vale might be a good alternative in the near future. So watch this space. I will definitely be reporting back on my experiences with it very soon. Next, two articles from Google. One from XDA developers by Michal Rahman on Android Q. Specifically, a feature of Android Q that is desktop mode. I have been following this kind of duality of devices and operating systems for some time. If anyone remembers, the Ubuntu OS, the Ubuntu phone, was attempting to do this, but I'm guessing that Ubuntu as a mobile and desktop OS were not quite mainstream enough for people to adopt it. And then we've had Samsung DeX and some other attempts. There's been various Kickstarter projects that have also tried to do this. But if Android Q supports it natively, thus getting native support for Samsung, I'm not sure if they will be depreciating DeX or not, but every other device, Pixel devices, I think pretty much any phone running Q, this could be quite fascinating. So you get to a screen and a keyboard, you plug in your phone, and I think USB-C facilitates this even more, I guess. And you get, I guess, a sort of a Chrome OS style interface to your phone. It will obviously need application developers to optimize their applications to work in this mode and a whole bunch of things, but it's quite interesting. While I would still rather have a proper quote-unquote computer than the somewhat restricted versions of Chrome OS/Android, it is an interesting development nonetheless, especially as I have covered many times, Apple and Microsoft are sort of losing interest in their own desktop OSs. Bizarrely, Chrome OS and Linux, mostly because Google are supporting Linux in Chrome OS, are becoming perhaps the only, if not most viable options available to anyone who wants a desktop computer. So I really look forward to trying this on my Essential phone, and that will get Q at some point. So I will get to try it at some point and to see how it works. But if you're interested in finding out some of the features ahead of time, or even if you have a Pixel device and want to test it yourself, you can do just that. Head over to the blog post to find out a bit more about the functionality and get hold of a beta version for your, probably not your mainstream device, but for one of your devices. Next, an article on ZDNet from Stephanie Condron on Google opening a privacy center in Germany. Now, this has been interesting. Google were trying to open a large campus here in Berlin. They already have a small office here, but they wanted to open one of their sort of large, like London-style campus offices here. And it was very much rejected and complained and campaigned against by local residents, and it's not happening. They are still going to open a much smaller, scaled-down office. But in the meantime, I guess maybe as some sort of compensation, maybe as some kind of dispensation, maybe just as a recognition of something that Google needs to do, and Germany kind of being one of the best places for discussing privacy because, well, in my opinion, Germany is somewhat obsessed with privacy, often to the point of extremity, but other countries are possibly not obsessed enough. So, sometimes you need mixtures of opinions to get to a good compromise. But this centre is opening in Munich, actually, not in Berlin. Munich is probably always a safer bet for these kind of corporate offices. But it is opening in Munich with the intention of hosting the Google Safety Engineering Center. This will be specifically to handle GDPR cases and, I guess, preventative and also reactive measures to those regulations, but also encouraging other engineers and other teams in the company to adopt privacy-first policies. So this includes recent Google Chrome cookie policy changes, for example. Early days, not much to hear from them yet, but I guess we'll see if this German influence has anything over Google's privacy policies moving forwards. And 2 articles in my "and finally" section, nicely segueing to my interview regarding Bosque coming very soon. This was an article on Hacker Noon from Danshuka Madushan on weird programming languages. Just a nice little listicle of some programming languages you've probably never heard of, maybe have no desire to ever look at again, and some of the strange syntax that they employ. I have not heard of many of these at all. These include languages like legit, folder, where everything is inside folders, which is quite bizarre. Befunge, where code is represented in 2D space. Brainfuck, I think the name probably sums it up. This is a language from the early 90s. It only has 8 commands. Piet, where you use a colored grid to program. And Malbolge, which is affectionately known as programming from hell. And it has an example in the blog post of Hello World, but apparently even the programmer of the language doesn't know how to write a program in the language, which is kind of bizarre. I don't know how you can even claim to have necessarily written it if you can't prove you've written it. But anyway, fascinating post. Always nice to see these kind of eccentric projects too. And finally, a post on City Lab from Robert English on why New York City stopped building subways. I have been thinking a little bit about this subject generally recently. I think because when we were back in Melbourne, and Melbourne doesn't really have a subway system, they have the inner city loop, which is underground, but it's not really an underground network. Or going back to London, where they have actually built several new tube lines, but just kind of knowing how long they take and just thinking when and how were all these underground lines built. A city like Berlin, for example, has many. They haven't really added very much to those recently. There is a U55, which is not very long and still under development. I guess they're taking a leaf out of the airport building project here. And what happened to make that rush of energy in the first place, and what happened to make it kind of stop? And this article focuses specifically on New York City, whose underground line is actually very old and hasn't added a new line since 1940. A New York story will be unique to New York. America is always much more obsessed with car driving, which answers a lot of the questions I had, but also city policies. New York went through decades of kind of underinvestment and governmental poverty, I guess, which would lead to a lack of investment in infrastructure. But it's interesting to see how the underground line in just under 40 years developed in New York, and then how it's sat pretty much stagnant ever since. Basically just in constant maintenance mode because it was so underinvested for so long. Any money for the transit authority has to go to keep maintaining and fixing instead of building new lines, which are very expensive. London has added a couple of lines, but not very many. And as cities become more densely built up on, of course, then it's harder and harder to build something like an underground line. So ironically, the bigger a city becomes, the harder it is to build the infrastructure that it needs. And of course, it's hard to pre-plan for the size of a city when you don't really know what's going to happen. Anyway, if you are even partially a transport nerd, I'm not really a transport nerd. I don't necessarily want to be labelled that way, but this topic just came into my head and this article appropriately popped up in my feed. I don't think there was any algorithm there, just pure coincidence, serendipity. Have a read. It's an interesting insight into finding out about how these networks that we take for granted may have grown. And now my interview with Mark Marron, I guess, and we do discuss the name he shares with a famous podcaster on the Bosque programming language, a new development language from Microsoft that looks to build a language that follows more modern paradigms instead of paradigms from the 1970s. Enjoy.
I actually wasn't attending Build this year. I was just been busy with some other stuff, but from everybody I've talked to, sounds like it was great. Had a lot of fun, and some great open source announcements too. So
for sure. Yeah. There's a lot of. I'm still kind of catching up with a lot of them, like some of the terminal things. I had an interview last week with the people behind Penguin. I don't know if you know that.
It doesn't ring a bell, but
it's just a distribution of Linux optimized for the Windows subsystem.
Okay, interesting.
And it's kind of interesting. I must admit, then when I tried to take it for a test run, I hit a few blocks, of course. But I don't know. I've always been a Mac user for a very long time, but I'm starting to kind of contemplate the Windows Linux subsystem combination instead. And I have a very kind of average Windows machine for testing, so it's not the best machine to get the best experience, but I figure if I enjoy it on that machine, then a better one will probably make it even better. But I don't know. I'm sort of delving more and more back into that world again after a long break. But,
I think that's a lot of people. Like I was at JSConf EU last year.
Okay, yes,
and we had a booth where some of the WSL people they were there. They were showing off, because Node.js and a lot of JavaScript folks, it's like they use Mac.
Yeah.
And they started using VS Code, but they were still on a Mac. And it was like, let's show them WSL and let's show them the new, the Surface laptops.
Yeah.
And people were just like, the screen on that's amazing.
Yeah.
I can do all my dev work with WSL. I'm using VS Code anyway. I think people really, liked that setup.
Yeah.
So.
Yeah. I used to be a big Atom fan, but I mean, it kind of got left behind, and now, well, they're both owned by Microsoft anyway, so it's somewhat, I don't know. Although for some bizarre reasoning on the Mac, Atom still renders nicer. I don't know if it's a theme I've got or something like that. I'll have to have a look into it, but for general support, I much prefer it. I do a lot of tech writing work, and so I tend to use editors. I don't use Word or anything like that. I don't know. I think I even let my Office membership lapse because I don't really use it.
Man.
So sorry.
Yeah, I agree. I mean, so we do a lot of paper writing in LaTeX, right?
Yeah,
and it's okay,
Yeah, no, I know.
For that, so
yeah, I used to use it a bit more in the past. Not so much recently. Bizarrely, I did some weird artistic stuff with it, which was kind of fun because it's very opinionated, and when you try to go against that opinion, it's quite interesting. But anyway, let's get stuck in. First, how do we pronounce the language name?
So it's Bosque.
Bosque. Okay.
Yes. So it's actually a Spanish word.
Yeah, no, for sure. Yeah, I recognize that.
Means forest.
Yeah. And are you Mark Marron?
Yeah.
Okay. You also share a name with a very famous podcaster.
I do. We're in a vicious search engine war for, did you mean? And I think he's winning hands down.
I think he probably wins, but you probably win in terms of your niche area, I think.
In my niche area. I claim one day I'm gonna come back, but we'll see.
Cool. All right. So I also do record calls. Generally, they go out as a podcast episode, and then they will go out as a kind of more hands-on article at some point, especially with Bosque, because it's a programming language. It's a perfect kind of use case to do that. That'll come a bit later. The written stuff takes me a little bit longer. The audio version will probably be in 2 weeks. As I say, I had already a kind of Microsoft heavy show last week, so I'll probably do this one the week after next because I have something that isn't Microsoft for next week, just to break it up a bit.
Yeah, that sounds good. Yeah. Like I said, with build going on, it's like there's no rush on
exactly.
that. There's so much that comes out there.
So, we'll run this as a conversation. So let's just kick off with who you are, where you work, and what you do, and then we'll kind of go from there into what the language is. Sure,
that sounds great. So, I mean, as you're saying, I'm Mark Marron. I'm in Microsoft, actually in the research group. The set of people I work with, we specialize in software engineering, programming languages, runtimes, development tools. So there's just a lot of work we do in that space, and obviously programming language research fit right in with that. So we started working on this question of, when I'm writing code, there's a lot of stuff that happens that isn't actually sort of solving the problem I want to solve. It's just things I have to think about as far as nuts and bolts moving around. And we wanted to sort of go back and ask ourselves the questions: is this complexity necessary? Do I really need this to make an application that works well for the task I'm trying to solve? Or is it just something that sort of gets in the way that I got to fight all the time? Mm-hmm. And if we sort of did a thought experiment in getting rid of that, what would that language look like? And that's really what sort of started to inspire this project.
Mm-hmm. And so what was the project that we're here to discuss today? What is that? And I guess you've given a kind of overall intention, but what problem were you specifically trying to solve with it? And how did you end up with what you ended up with?
Well, so let me say this. So we sort of didn't have necessarily a problem that we wanted to solve so much as a question we wanted to ask, right? So in the research group, we're kind of lucky because we can not necessarily focus on business objectives or, what is the engineering problem at hand. We just want to sort of ask some interesting questions and see what falls out of there. So, the question we wanted to ask was, if we go back and start from a perfect blank slate, and we want to get rid of all the complexity we can in a language in terms of when I'm writing a line of code, how many things do I have to think about? Can we minimize that number of things? And what does that look like? And we just wanted to ask that question and start from there, and then try and figure out how that might work and where that might go. And we're sort of in the first steps of that, where we had some ideas, we tried to put them out there, and now we get to have some fun iterating on that and seeing where it leads.
And so you ended up with this programming language you're calling Bosque. Firstly, is there a story behind the name?
No, I'm not very good at naming things. So, generally, internally, there's a strong push like, hey, don't pick a name that is generic or conflicts with other projects. And, so they have a very nice tool that just recommends some names.
Okay.
This name came up there, and I was like, well, that sounds like a pretty good name. Forest kind of has a nice connotation, doesn't conflict with anything really too much when you search. And so I went with it, nice and easy. I'm not as clever as other people.
Obviously, Microsoft already maintains a handful of language names that are mostly single letters, so bar a couple of them. So I think it's a little overdone, I guess. And what would you, how would you describe the basic style of the language? People describe languages as being Python-esque or Ruby-esque or JavaScript-esque. What would you describe Bosque as, kind of from a top level?
From a top level, so I think I've spent a lot of time recently interacting with the Node community in TypeScript. So I was really inspired by some of the way those languages were set up in terms of syntax and the type system and the general block structure and flow. As a grad student, I also really enjoyed writing code in ML, this meta language, standard ML of New Jersey. And that sort of inspired a lot of my thinking in terms of functional programming design and writing code without loops and how that might look. And so we sort of took these two languages as a general inspiration of starting point and sort of merged them together. So if you look at the code and you're coming from like a TypeScript or a JavaScript background, it should look very familiar, especially if you're used to writing code with like underscore or Lodash in a more functional style. It should be pretty natural for you.
And are there any particular application use cases you think it will be suited for, or is it fairly general purpose?
At this point, that isn't our priority. We just sort of wanted to understand what the implications of some of these design decisions and different perspective for thinking about what a language does and how to put it together. So that's a little bit further out, but kind of from what we've seen in people trying to write applications for the cloud, particularly if you're trying to do a serverless style application, it seems like it might fit in very well in that niche. But again, it's early days, and that's not really our focus. We're more just want to explore the ideas.
So digging a little bit behind the theory here, there's sort of two terms that you mention a lot in the descriptions that maybe we should just unpack for anyone who's a little unfamiliar. So you mentioned kind of in your justification that a lot of programming languages are still somewhat based on the structured programming style from the 1970s, and that Bosque is much more in this functional world. So for people who are not familiar with what those two mean, what would kind of your summary of the differences between those two language styles be? Sure.
So I think let's go back to sort of structured programming. Mm-hmm. So as you said, this sort of came to the fore in the 1970s. And previously people were using, go-tos and just arrays of bytes more or less as their primitives for composing programs. And for anybody who's tried to write code, in assembly or in using jumps or go-tos, you can do some clever things, but it's very difficult to write large, composable, modular pieces of software. And so the big insights there were, well, really when people are using go-tos, they're using the same patterns of these go-to jumps over and over again. And rather than sort of manually writing out all the details, we should introduce these higher level concepts called loops. And you have for loops and while loops. And these are patterns that encapsulate the things people really try and do with go-tos in much more compact and understandable representations. Mm-hmm. And similarly with the introduction of abstract data types, they said, well, instead of having an array of bytes, which you need to manually remember which index is which field in a record, let's create a record concept that just encapsulates all of this very nicely. So you can see it as a both raising the level of abstraction that people are writing code at, but also capturing common things that people try and do and removing all this incidental complexity about having to manually re-implement this every time and make it just a primitive in the language. And so that was a big revolution in how people could build software reliably, modularly, and deploy it effectively. So that's sort of structured programming and how that evolved. And of course, you see this really carries along the imperative nature of I'm on a VAX or an x86 today where I have a program counter, I have memory, records live at a certain location in memory. The other vein I talk about was this sort of ML family of functional languages. And these maybe come from maybe a bit more, let's say, mathematical perspective, where I have functions as like a mathematical function. It will take in a value, which is some abstract record or tuple. It doesn't necessarily live at a memory location. And I will never mutate that object. I will just compute new derived values from it, and I will return a derived value at the end of the function. So much more sort of mathematically based. And people sort of favor this functional approach for reasoning because you don't have to deal with some of the complexity of mutation and side effects and what things might change during the execution of the function.
I must admit, because the functional world is something I've been to lots of talks on, but I've never had any particular need for it in myself. So I sort of still am partially understanding it. I get the concepts without ever having had to use them, so without having the practical knowledge of them. But I know there was a lot of conference talks around functional languages a couple of years ago. And would you say that's still kind of a very popular programming paradigm at the moment? Or
yes, I mean, absolutely. And I think, as you say, for a lot of people, it can be a little difficult to get used to programming in a functional mindset. And I think from an ergonomic standpoint, in the sort of traditional functional programming languages, like if you look at Lisp or Scheme or ML or OCaml or Haskell, they're very interesting. They're very powerful, but they might have some features that make them a little uncomfortable for people to use in many cases. And, this is just almost an aesthetics thing. But if you look at even the way sort of JavaScript has been moving, it's been really adopting a lot of sort of the principles or the paradigms of functional programming, but putting them in a way that's more accessible and maybe more ergonomically amenable for developers. So, if you look at libraries like Lodash or Underscore, Immutable, these are all basically bringing this sort of functional processing and immutable data to JavaScript because it's easy to write code quickly that puts these pieces together in a way that doesn't surprise you. I think a great example of this is, people in the React and Redux community, where rather than having some sort of state object and UI tree that you manually mutate and update as you go to get an updated UI, you have a state object. And from that object, you functionally render your UI. And if you want to change that state, you create a new state object and can re-render your UI in this pure manner, right? And so this is a very functional concept. And it's very powerful, and it makes it very easy to, sort of reason about and change some of this behavior. And you can see they've put it together in a great package that is really accessible to developers and is really allowing people to build some great stuff. So, I think that's the challenge, is how do you get some of these core ideas that are really powerful and expose them in a way that really matches what people are trying to do, and it doesn't trip them up somehow.
And why do you think people would be reaching for a functional language? Is it due to the growth of cloud computing, and even then taking that to the extreme, the serverless computing, because it's easier to not have to worry too much about state, or are there other reasons?
Well, so I think what you said is worry about state is sort of the crux of it. So the beauty of a functional language is when I call a function, I know that the only thing it's going to do is return a new value. I don't have to wonder, is it going to mutate the first parameter? Is it going to update some global state that I wasn't expecting? Like this is the sort of accidental complexity I think we refer to in the paper. I don't have to worry about any surprise side effects. Looking at that line of code, I know exactly what I can expect it to do without having to look at the implementation at all. And so that's what enables people to sort of start building more modular software and quickly integrating and testing these components, because they don't interact in spooky at a distance ways, right? And so, that was sort of one of the things we took inspiration from, is here's a great way where you can eliminate accidental complexity, make it easier to build software more quickly and more confidently. Where else can we do that?
So let's dig a little bit more into some of the language details. I'm mostly drawing here from your language overview on the GitHub repository.
Sure thing.
So not the first paragraph, but the kind of the first paragraph that isn't table of contents. It's a little bit down the page. One of the things that grabbed me, because there's a reason I'm going to get into this, and I may go off into areas that are not completely relevant to the language. We'll see. That you say the language is designed for writing code that is simple, obvious, and easy to reason about for both humans and machines. That final part of the sentence is quite fascinating in its own way, for humans and machines. Yes. I don't really know what you might mean by that. That's a kind of mysterious statement.
Yes, I'm happy to elaborate on that, but we can come back if needed.
No, yeah. Sure. No, I think now seems a good time before we delve into other details here. What do you mean by that?
So I'll let me tell a little bit of my history and story. So I was a bright-eyed, bushy-tailed, eager-to-go grad student, and I said, well, I should tackle an important problem. And I was very interested in compilers, and I read a great compiler textbooks, and I read compiler papers. And they all had amazing optimizations you could do. You can make your code faster. You can make your code smaller. You can make your application, behave more predictably in terms of runtime performance and jitter. And I was like, this is great. We should implement all of this. And as I was reading through the details, I saw that most of them said, in order to do this, I need to understand in detail the way the application has allocated memory, and the way pointers are sharing memory across, data structures in the application. And so I said to myself, well, if all of these depend on understanding pointer analysis, and that is a key problem to enabling amazing compiler work. So as a grad student, I should attack this important problem, and I should solve the pointer analysis problem, and that would be a very important result. And so I spent many years working on this, and I got some interesting results. I think I published some nice papers. But what I learned was that doing pointer analysis was very, very hard. And one of my favorite papers from the mid-90s, I believe, or early 2000s, is called Pointer Analysis, Why Haven't We Solved This Problem Yet? And, it's 20 years later, and many more papers have been published on pointer analysis. There are many interesting ideas in them, but it's still an unsolved problem. And it seems that there are just fundamental things about like object mutation and the aliasing relation that make it very, very potentially permanently impractical to have as a general purpose analysis for a language like Java or C Sharp. And so one of the reasons to eliminate these sources of accidental complexity that we talk about here is not only are they confusing for humans, but they also can make automated reasoning about code to answer questions that would enable incredible compiler optimizations or enable you to find deep, subtle bugs without having to do testing or without relying on users to report them, are prohibited by these types of complexity that creep in. So the goal is, if we eliminate this, can we make it easier for humans to understand what the software is doing, but also make it easier for automated tools to understand what the software is doing and provide you either better performance, better bug finding, or the ability to, if I'm doing like a semantic version update, is it going to break is it a patch? Right now I have to sort of do this is like, what is my gut intuition as a developer? But we'd like to verify that if you think your update is a patch, that it really is a patch. It's not going to go break somebody's software if they update to the latest version of your package, right? So, this ability to automatically have mechanical tools support you was something we also were hoping to make progress on by the elimination of complexity here. And for me, get some closure on my PhD thesis.
Sometimes it can take some time.
It does.
It's quite fascinating. I think you've sort of opened up a whole world of potential applications there, which could probably be an entire discussion in itself. So there's quite a lot packed into that mysterious half sentence then.
Yes.
Yeah. Okay. I think
we're not there yet, so I want to.
No, for sure.
Right? I mean, I think this is one of the things that we're really excited about going forward is exploring more in this project. So
yeah. But the first half of that sentence was actually the bit that first grabbed me, and I think now is probably less interesting than what you've just said. But I'll go with it anyway.
Sure.
And that was simple, obvious, and easy to reason. And I think the thing that is fairly clear with a language like Bosque is that whilst they may be true to the sorts of people who want to use it, I'm guessing the language isn't really designed for a beginner to programming. It's designed for people who have probably been using other languages for a while and have hit some barriers with those and are looking for something to solve particular problems. It's not something that's really aimed at beginner programmers, or am I making some assumptions there?
Well, this first sentence, and I noticed there were several comments about this in various searches.
And I have a very specific reason for asking this question, which we'll get to into in a minute. But yeah,
sure. Simple and obvious, they're very loaded terms.
Yeah.
Right? And you can come in and you can say, well, a simple programming language is one that has the fewest numbers of primitive operators, right? Or the simplest context-free grammar that describes the syntax of the language. That's one definition of simple. And, I think Bosque is probably not the simplest language from that metric. I think what we were going for more in terms of simple is, if I look at let me put it this way, it's sort of a principle of least astonishment. And this is sort of a term that comes from if I'm building a UI and I have a user that's going to click on a button, I want to sort of follow the principle of least astonishment. That is, the least unsurprising thing should be happening when they interact within a UI element on the page. And so that was sort of the version of simple and obvious that we were going for. That is, if I look at a line of code in a Bosque program, it should be, in a sense, very boring. I should not be astonished in some way that it changes some global variable or some mysterious thing happens. I should look at that line of code. I should be able to see what the arguments in are. I should be able to see what the result is. And I should not really have to go understand much else about the program to understand what that line is trying to accomplish, in a sense. So that was the notion of simplicity we were going for. Now, as you say, from a beginner, the language is more complex to learn than some others because there are more, let's say, primitive concepts that you would need to understand in order to look at a block of code and know what that block of code does. But once our hope is that once you've passed this initial hurdle of picking up the primitive concepts, that as a beginner, it becomes much easier to learn to write interesting programs in because you don't have to suddenly learn that there's this thing called global variables that change mysteriously, or that there is by reference versus by value parameter passing, and they have different implications on how a method may mutate some variable mysteriously for you. So in that sense, if you're talking to a beginner and you say, oh, this function takes arguments, this record and that record, and it returns a third record, that's very simple for them to understand. It's a very simple concept to understand. If you say it takes this record and that record, but it's going to mysteriously change the first record while you're calling it, then that can be more confusing for some people. Yeah. So it's a bit of a trade-off. I think we'll have to see. There's been some lively discussion on the GitHub repo on various syntax choices, so it'll evolve.
Yeah, and actually, it's interesting how you answered that, because the particular reason I had in the back of my mind for asking this. So I predominantly come from more of an educated background. In addition to kind of doing the in quote marks tech journalism stuff, I do technical writing, I do training materials, things like that. And I had an experience a few years ago where here in Germany we had the big influx of Syrian refugees, and there were one of the various schemes that was run was a coding school. Oh, yeah. And we were teaching Ruby on Rails to these refugees. And something that really stuck in my mind was that to more experienced programmers, something like Ruby and then Rails was good at the time. It's sort of not as popular as it used to be because it abstracted a lot of this kind of boring boilerplate code that experienced developers got bored with. But of course, for a beginner, abstracting all this meant that they didn't really know what was going on. And you would have like a kind of shorthand loop, for example, and an experienced programmer would think, wow, what great syntax. It's just like 4 characters or whatever. But an inexperienced programmer would look at it and not have the foggiest idea what was going on because it abstracted so much. Whereas using something very verbose like PHP or meant like it was ungainful but it was also very simple because you could see exactly what was happening. And you would learn. And then, of course, in a year's time, you'd probably think, oh, my God, this is horrible syntax. I'm going to learn something else that's more abstracted. Yeah. But your answer there was actually kind of interesting because you kind of lose one thing but gain another. So if those sorts of languages have their positives in that way that they're very easy to understand, but then they're very hard to understand because you have a lot of this kind of convenience mechanisms that aren't always clear what they're doing. And you get stuck very quickly because something kind of auto-magical is just happening. But like, what was it? I don't know. So yeah.
And I think another interesting example here you sort of touched on is loops, right? Yeah. Like when a developer, a new student comes at programming, and you say, well, suppose I have a list of objects, and I want to do the same operation on each one of them. They're like, yes, I understand that. That's a concept I understand. And if you say, well, here's a thing called map, which does that for you, or filter, which does that for you, that's great because they already have that intuition and they can just use it. But if then you have to say, oh, let me tell you about this thing called a loop. And, there are different kinds, and now you have indexing bounds, and you have to pick your iteration order. That's something that, again, you have to introduce all these concepts that aren't actually relevant to accomplishing the task that they want, and actually obscures, like I have a for loop. Well, is it a filter? Is it a map? Is it, a min or a max? Well, now I have to go look at the individual operations, low-level operations, to answer the question about what was I trying to do, right?
Yeah. Yeah, it's a very good point. Things like map filters and even with sort of the world they come from, like maps and reduces and functionalities. I never really thought of it like that. I have come back into JavaScript after a fair break, when things like maps and filters didn't really exist, and it took me a little bit of time to get my head round them, even though I kind of knew what they were for from having also done some previous work in NoSQL databases. But I couldn't quite connect the two because I was so used to using loops for things.
Yeah.
But you're right. Actually, once you do, you kind of switch your head round to thinking, well, I want to basically work over a set of data and do something to it. And yes, loops were just the way we always used to do that. It doesn't mean they were the best way. In fact, we're now starting to realize they're not. It's actually it's a good perspective. Like, I think from someone like myself and many people who have come from this structural background, we kind of look for things that are missing instead of looking for ways to accomplish what we want to accomplish, I guess.
Yeah. It was interesting. Yeah. It's a little aside here, but sort of as a warm up to this project, because we did have this view that, hey, loops, if I'm a functional programmer, filter map reduce, that's all I need, right? And if I'm like a C++ programmer, it's, I need fors, I need whiles, I need, to be able to do all this crazy indexing, right? That's how you write iteration in C++ or C# or Java. And we were kind of like, hey, where is there some way we can do an empirical study of all the loops that people are writing in, hundreds of thousands of lines of C# code, and actually see how many different conceptual loops or idioms there are for writing these loops? Like, are people writing the same patterns over and over and over again? Mm-hmm. Or are people writing actually radically different loop behaviors? And no matter how many lines of code we look at, we still see new idiomatic behaviors that are coming out. And so I had a great intern who had done some work on applying statistical machine learning methods to source code. And we were able to go and look at, several 100,000 lines of C# code, identify and classify the structure, the idioms of the loops that you saw. And when we say idioms, it's like, for blank equals 0, blank is less than, a dot length, blank plus plus. And you're like, oh, okay, I'm going through an array, one element at a time. And then in there we see an if body with a copy to B, and we say, oh, that's a filter, right? That would be an idiom we would identify. And we basically were able to learn and find a very nice saturation curve and say that, hey, basically 95% plus of all loops you see in 500,000 lines of C# code can be classified into a reasonable set of these filter, map, reduce, group by, these functor operations you would expect to see. And that was really inspiring, and, drove some of this work to say, hey, people are writing the same operation over and over and over again, just as a loop, because that's what they have, not because there's something intrinsic about it that they really need.
Yeah,
I mean, there are some cases where you need unstructured iteration, but just like GoTo, it seems to be a very small set of actual cases that you really do need a GoTo, or you do need an unstructured loop.
Yeah. I mean, the language overview is obviously fairly long, so just to pick out a few other, I guess, elements that will be familiar. So you do retain the kind of classical control flow, like if then else. And there's no surprises there. It works exactly the way most people would expect.
Yes.
Yeah. What would be some of the other kind of? I mean, I'm now kind of scrolling up and down your page, realizing there's many, many, many things we could talk about. So, to you, what would be some of the other kind of, let's say your favorite highlights of the language design that you're particularly proud of?
Sure. So, I mean, I think, on a lot of things, we went for like, hey, people have done a lot of great stuff in programming languages, programming language design. Let's borrow some great ideas and polish them up a little bit where we can. So one example of that is non-nullable types. There's been, TypeScript does this, Haskell has done this kind of thing for years. So we just wanted to go and take this notion of non-nullability and Elvis operators and just make sure it was unified throughout the operations you could do and make it really easy to use. So the language has nullable types and non-nullable types, and it has an easy way to unpack all of these very clean. Just borrows a lot from TypeScript, really. But I think that worked out very nicely. Another one which is a little more interesting, and I've seen some early versions of it, and if I fail to mention a language that has this, I'm very sorry. We tried really hard to try and credit languages that have done this first, but it's a big space and sometimes we miss things. But one challenge that comes up a lot in functional languages is I have a record of 10 fields, and I want to update 2 of these. So now I need to write code that sort of creates a new record, copies 8 of those fields, and puts 2 new values in there. And this is both very boring to write, it's easy to get wrong, and if I add an 11th field to that record, I now need to go everywhere where I was doing this sort of copy update constructor and add that new field. And so now I miss it and my code's broken and it's surprising. So F# has the ability to say, I want to take a record and I want to change some set of fields in that record and copy all the rest, but I don't have to specify all the rest. So it's sort of doing like a bulk update copy thing. And this is very nice because it eliminates the need to do all of these individual atomic operations. It sort of captures what you want to do, again, more clearly in the code. I want to take that record and change these 2 fields rather than talking about each field individually. And it also starts to give your code a bit more algebraic flavor. Like rather than talking about individual fields, I'm talking about sort of doing algebraic operations on records. And we wanted to take this idea and run with it a little bit and say, hey, if I'm doing sort of this algebraic transformations, I don't want to just update, but I want to project, I want to merge, I want to do all these other things. So we have what we call bulk algebraic data operations. And what this means is, like, if I have a record and I want to get a new record with only a subset of those fields, I can project those out. And if I project out a couple records, I can merge them together in atomic operations. I can even take a record and project out a new record of a given subtype. So this makes it really easy to sort of start just moving these data chunks around as atomic things rather than continually having to destructure and restructure them.
I think I could start to see how that would be useful. And one of the you've got another sort of to me feels slightly related to that. I guess just in terms of data type flexibility, is typed strings concept.
Yes.
Which so instead of just having a generic string, you can have a string of well, you've got here an example of zip code or something like this, or string name, for example. I mean, how subtle can this be? Can you then, at some other point in the language, define some kind of validation for that?
Yes. So this is thanks for bringing this up. This is some great work that I was able to do with some collaborators at the University of College London, and it's very nice. So, like the idea is that strings are sort of the universal dumping ground for data that's structured, but I don't actually want to go and create an object for it and everything. And so, but the danger is you end up with APIs that are like, foo takes string, and as what are those strings supposed to mean? I can easily get parameters swapped, and we want to just give a little more structure to that string. And what these type strings do is they allow us to sort of parameterize what values of a string can be in that object based on some type that we know about. And that type that we know about, so in our example, zip code, there would be a class called zip code somewhere in your program, and it would have a method called try_parse, which basically defines a parser for a string that either accepts the string and returns an object of the type or returns none. And the contract is that if you have a string of zip code that if you call zip codes try parse on that string, it will successfully parse. So the user can actually extend this arbitrarily for whatever particular types and strings they care about in their application. Now, in Bosque, we just did this try parse. So you manually have to write this parser yourself. And that means it can be as complex or simple as you want, but it is a bit, at this point, it's a bit heavyweight and cumbersome. You do have some boilerplate on it. My collaborators at UCL experimented with some nice stuff. Like in a lot of cases, the parser is really nothing more than a regular expression. So can you basically do something like a type def? The zip code is some regex, right? And it would automatically build the class and that string subtype for you. Or if you use parser combinator grammars or some other things, can you actually have a decidable type system on these string subtypes? So this, you actually have a lot of power there in how you build these.
Yeah, that's quite fascinating. I could start to see how it would force programmers to really think about this, because the reason a string is a dumping ground is, let's take for example a zip code. A zip code takes multiple different formats around the world, so you'd really have to be very careful about how you create this parser to match all those patterns. Otherwise you would get errors very easily, where the traditional approach would be just use a generic string and anything's accepted. So, which is easier to code, but may cause further problems down the line. So,
Now, the nice thing with this is that by sort of lifting this type into the nominal type system, like zip code is just a class, basically. Yeah. You get all the subtyping on the string that you would get on the class. So as you say, I might have an abstract concept of zip code, and I might have specializations for the US, the UK, Germany. This is where I get into the weeds. I don't know how many zip codes, but you can subtype all of them. And then the string of zip code would actually know to check all of those subtypes as well. So it does structure pretty nicely there.
Yeah, that's quite a fascinating idea, actually. We're starting to run out of time. We've barely touched the surface of what's in here. So I strongly suggest people go and have a bit more of a dig. But let's go upper level a little bit. So what do you intend the language to be? Is it a compiled language, an interpreted language? How is it run over some code?
So today, like I said, we wanted to get this out there early to get people's feedback. If people want to, participate and contribute, we wanted to sort of let everybody get on the ground floor at the same time as we did. So the runtime today is just a very slow, very simple interpreter written in TypeScript. It just gives us sort of a reference semantics for what the language should do or we think it should do. Going back to what I said earlier, as a grad student, I was very excited about compilers and opportunities to do more efficient, novel compilation. And so my hope is that as we develop some of these machine reasoning methods, we're able to go and start building some very advanced and high performance compilers targeting, I think two targets of interest for me are WebAssembly and just going maybe to machine code via LLVM and LLVM backend. So those are sort of the two things we'd like to target, but really this is sort of experimental. So we'll try some things. If they don't work, we'll, adapt and try other things. We really want to learn as we go. So I think there's a very open-ended set of compilation targets. We haven't committed to a specific, canonical runtime at this point.
And if people are interested in getting involved and finding out more, you already have a fairly active GitHub repository. I don't know when you started this project, but I mean, in terms of GitHub history, it's fairly recent. I'm guessing there was a lot of work done before that.
We've been doing. It's probably about a year of sort of prototyping.
It's not bad. It's not bad.
Not bad.
It's not bad at all. Yeah. But you do have, it's actually a pretty comprehensive repository here. And as you said earlier, there's already some healthy discussion going on. A little, not so much on the pull request, which would make sense, but a lot of issues, which is probably people discussing, I guess.
Yeah.
And maybe taking issue more than anything.
That's good. That's good. We like feedback too. You don't have to have a solution if you have a thought or, it's a research project, right? It's great to get the ideas.
So there's some steps here about building and testing and command line execution. One of my questions was going to be the file extension. It's BSQ. I do know there's another open source project out there called Bisq, which I wonder if has a similar file extension, but it's a very different world, so I wouldn't worry too much. And of course, you're also providing some very basic Visual Studio Code integration, which makes a lot of sense, especially with that current TypeScript ties, I guess.
Yeah.
And well, obviously it's very new, very early days. You've already, and the repository is littered with to-dos and not implemented yet and ideas and things like that. But I guess kind of if I was to hold you to a handful of points, what's kind of on your immediate roadmap of things you want to do next?
Well, so I think there are two things that are big priorities for us. As I mentioned, one of the big questions we had was, this eliminates a lot of complexity that potentially enables deep understanding and reasoning about source code. And that is, at this point in time, a belief. We've done some hand studies, but I have a couple great interns that are going to come and try and build very sophisticated symbolic analysis engines for the source code, both for correctness and to be able to say this particular application is entirely free of bugs, or this application may crash and here's a witness input that will cause that crash so you can debug it. And also to do resource analysis. So what is the big O complexity of your entire application? How does its runtime scale as a function of your input? What is the max memory that you can use? Those are some pretty foundational questions that we would need if we want to build any sort of sophisticated tooling. They're also sort of a limit test of how far we can push automated reasoning. And I think that's something I'd love to answer sooner rather than later. So I'm going to have some great students. They're going to come and work with me over the next 6 months on that kind of stuff. A little larger is this question of Bosque does not provide any I/O natively. It's kind of like JavaScript. It doesn't have its own I/O libraries. It depends on a host to drive it and drive its interaction with the environment. And what we think those hosts should look like is unclear at this point. So we need to do a little sort of design experiments to understand what those hosts could look like. Do we want them to run on the command line? Should they be sort of cloud and serverless focused based on like webhooks or something? And what sort of environment should they provide? So that's a little bit sort of abstract design. But those, I think, are two things that are, in my mind, the most pressing and the most open questions around the language. There's a lot of other stuff that's fun and great, some type system stuff, playing around with compilers a little bit, but I think those are the two that we want to focus on right at the beginning.
Yeah, cool. And for those who are interested in digging further, the GitHub repository is github.com/Microsoft/Bosque. We better clarify the spelling of that, BOSQUE language. And you also have some the base research papers and I guess setting out the aims of the project on the Microsoft research site. That's quite a long URL, so yeah. I may not read it out. But
they're all linked through the GitHub repo as well.
Go to GitHub, yeah.
Try to keep it easy, compact, one-stop shopping.
That was my interview with Mark Marron from Microsoft. As mentioned earlier in the show, I have a lot of interviews to process right now. I am about to edit the second episode of The Enthusiastic Amateur. I have all the interviews from KubeCon, and I have some other interviews I'm also going through too. And I am about to set up recording for the 3rd episode of The Enthusiastic Amateur, so plenty coming there. If you happen to be in Vilnius, Minsk, or Krakow in the next week or so, I will be at events in all of those cities. So you can find more details at christianjollett.com/events. I've been getting back into the momentum of blog posts recently. So also on christianjollett.com, you can find some of the recent blog posts I've written. And I've back posted a bunch of articles I've been writing for Cowrie over the past few months as well, which were missing for a little while, in case you're wondering what I had actually been doing. If you've enjoyed the show, please find previous episodes at christianjollett.com/podcasts and the accompanying newsletter at the same website /newsletters. And you can contact me also on the same website. Please rate, review, share wherever you listen to the show. The audience numbers are slowly growing, actually, and I'm about to start some advertising campaigns. So hopefully we'll get a little bit of an influx soon. And I'd always love to have your feedback about anything I have spoken about. But in the meantime, if you have been, thank you very much for listening.